Summary. A solution is a homogeneous mixture of two or more substances. What kind of a mixture? Homogeneous mixture. Solutions can be classified as solid, liquid and gaseous solutions. How to express the concentration of a solution? Concentration of solution is expressed in terms of mole fraction, molarity, molality and in percentages. Dissolution of gas in a liquid is governed by which law? Dissolution of gas in liquid is governed by Henry's law. And what is Henry's law? At a given temperature means temperature is constant. Solubility of a gas in a liquid is directly proportional to the partial pressure of the gas. Vapor pressure of the solvent is lowered by the presence of what kind of solute? Non-volatile solute in the solution, and this lowering of vapor pressure of the solvent is governed by Raoult's law, according to which the relative lowering of vapor pressure of the solvent over a solution is equal to the mole fraction of a non-volatile solute present in the solution. However, in a binary liquid solution, binary means one which consists of only two components. If both the components of the solution are volatile, then another form of Raoult's law is used. Mathematically, this form of Raoult's law is total pressure is equal to pressure of the pure component 1 multiplied by mole fraction of the component 1 plus pressure of the pure component 2 multiplied by mole fraction of component 2. Solutions which obey Raoult's law over the entire range of concentration are called ideal solutions. Two types of deviation from Raoult's law. One is positive deviation and another one is negative deviation. Azeotropes arise due to very large deviation from Raoult's law. The properties of the solution which depend on number of solute particles and are independent of their chemical identity are called colligative properties. Means colligative property directly proportional to number of particles and colligative property is inversely proportional to molar mass. So, the properties of a solution which depend on number of solute particles and are independent of their chemical identity are called colligative properties. These are, what are the colligative properties? First, lowering of vapor pressure. Second, elevation of boiling point. Third, depression of freezing point. And fourth, osmotic pressure. The process of osmosis can be reversed if a pressure higher than the osmotic pressure is applied to the solution. Colligative properties have been used to determine molar mass of solutes. Solutes which dissociate in solution exhibit molar mass lower than actual molar mass. So, solute which dissociate in solution, their number of particles increases, colligative property increases, and when colligative property increases, molar mass decreases. Therefore, solutes which dissociate in solution exhibit molar mass lower than the actual molar mass. What is actual molar mass? Actual molar mass is calculated from the molecular formula, and experimental molar mass is obtained from colligative property. And those which associate show higher molar mass than the actual values. Solutes which associate, in those kind of solutes, number of particles decrease, colligative property decrease, and when colligative property decreases, experimental molar mass is greater than the actual molar mass. Therefore, those which associate show higher molar mass than their actual value. Quantitatively, the extent to which solute is dissociated or associated can be expressed by want of factor denoted by the alphabet I. This factor has been defined as the ratio of normal molar mass to experimentally determined molar mass, or as the ratio of observed colligative property to the calculated colligative property. So want of factor or I is the ratio of normal molar mass to experimentally determined molar mass, or as the ratio of observed colligative property to the calculated colligative property.